We have been chasing this idea of an infinite context window for what feels like years now, treating it like the holy grail of AI.
It's been the goal, for sure.
But there's this massive paradox emerging. Just making the window bigger seems to actually break the model.
It really does.
We're talking about huge systems, like GPT-5, just stumbling when you give them 10 million tokens. Researchers at MIT are even calling it context rot.
Yeah, it's the classic quality versus quantity problem. When you force that much data into a standard transformer's attention mechanism, the signal just gets lost in the noise.
So it's not just forgetting things.
No, it's worse. Its whole ability to reason just collapses because it's trying to pay attention to literally everything at once.
Okay, so the solution from MIT isn't about building a bigger brain. It's about changing how the brain accesses information.
Exactly. They're proposing something called Recursive Language Models, or RLMs.
Right, but this is the part that feels strange to me.
Yeah.
The paper talks about treating the prompt less like text and more like a coding environment. That just sounds weird.
It does sound a bit counterintuitive, but think of it like this. A standard LLM is like someone standing at the door of a massive library trying to memorize the spine of every single book all at once.
Okay, I can see how that would fail. The pixels would just blur together.
Precisely. Now, the RLM is more like a researcher who's already inside that library sitting at a desk with a laptop.
They're not memorizing the room.
Not at all. They walk to a specific shelf, pull down one book, read a single page, take a note, and then put the book back. The coding environment is just the laptop.
So it's not a chat box anymore.
Yeah.
The AI is basically working inside the coding terminal.
That's the technical reality of it. The RLM loads all that text as a variable inside a Python REPL, a readable print loop.
And that lets it write code to interact with the data.
Yes. It can split the text, peek at certain lines, and this is the crucial part, it can recursively call itself. It spins up these little submodels to process specific chunks.
But hold on. If the researcher doesn't memorize the library first, how do they know which shelf to even walk to? Isn't the model just flying blind?
That's where the coding part is so clever. It writes little scripts to scout the territory first.
Okay.
Take the Browse Comp Plus test from the paper. The task was to find the winner of a beauty pageant from a specific town festival, and the answer was buried in a stack of 1,000 documents.
Which is exactly where a standard model would just give up and hallucinate a name.
Precisely. But the RLM didn't even try to read all 1,000 documents. First, it wrote a reject script.
Regular expressions.
Right. To just scan for keywords like festival and beauty pageant. It's basically a keyword search.
So it's not reading. It's using Control-F to cheat its way to the right paragraph, and then it reads.
You can call it cheating, or you could call it efficient triage. That code immediately pointed to chunk 6 as the relevant section. Once it found that, the RLM triggered a recursive subcall, a mini-me, basically, and its only job was to read that one chunk. It extracted the winner's name, Maria Dalmasio, and then it even ran a self-verification step to double-check the year.
That distinction triage versus just reading, that has to be the key for more complex tasks. The paper mentions the oolong pairs test. I know that's a beast of a benchmark.
It is. It requires multi-step reasoning, not just fetching one fact.
Wow.
And this is where you really see context rot in action.
The base models just failed.
Completely. Models like GPT-5 and Qwen3 coders scored near 0. They couldn't hold the chain of reasoning together. But the RLM wrapper,
It works.
it shot the score up to 58%.
Wow, from 0 to 58. But I have to play devil's advocate on efficiency. If it's writing code, running searches, spawning subagents, isn't that burning through compute credits like crazy?
Surprisingly, no. It's often cheaper. Because it filters the context with code before it commits the expensive neural network to reading, it avoids processing millions of totally irrelevant tokens. Think of it like skimming a table of contents versus reading the entire encyclopedia.
So we're moving past this idea of an AI as just a passive reader that gets overwhelmed.
We are. We're changing the definition of context. It's not a memory limit anymore. It's a resource to be managed. The model isn't just predicting the next word, it's investigating the prompt.
That feels like a fundamental shift. We always thought reasoning emerged from reading enough text, but MIT seems to be showing that reasoning might actually emerge from deciding what to read.
And that leads to a really provocative thought. If these models are now writing code to debug their own understanding of a prompt, are we maybe witnessing the beginning of genuine recursive agency in AI?
A lot to think about next time you see that chatbot typing animation. Thanks for diving in with us today.